Hi friends, so this is Amit Srivastav and today we are going to talk about Java virtual threads which are a part of Java version 21. So first we are going to see the different types of threads. So we have OS threads or the operating system threads, we have the platform threads, and now we have virtual threads. So OS threads are basically those threads which are created by operating system, and their count depends on the um, available CPU cores of our machine and also like the available processors. So if you have a quad core machine with 4 CPU cores and 8 available processors, we are going to have 8 OS threads, and these are the ones which actually or eventually performs the tasks which we assign to the Java platform threads. So let's see visual representation of the same. So here in the gray arrows you can take that as the OS threads. So we have a if we have a dual core machine with two CPU cores, then we are going to have 4 OS threads available to us, created by the operating system. And now let's see the platform threads. So basically these are the threads which gets created when we create any new thread from our Java applications. They are the abstractions provided by the JVM over OS thread, and they are costly to create because upon creation, operating system allocates a large amount of memory in MBs for each platform thread in the stack area. So if we create a platform thread, then say 1 MB of space will be allocated by the operating system in the stack area for that platform threads. And if we create n number of platform threads, that memory area will lead to n into 1 MB. So here comes the limitation in the number of platform threads that can be created. And if we exceed that count, we are going to run into out of memory error. And once scheduler prints a platform thread, this large amount of memory has to be moved. So which is a time consuming and costly operation. Before moving on to the virtual threads, let's again see a visual representation of platform threads. So these blue arrows, you can take that as a platform thread. So whenever a Java application is going to create a platform thread, the operating system is going to allocate 1 MB worth of space in the stack area to that platform thread. And if we create large number of platform threads, then more space has to be allocated by operating system in the stack area for the platform threads. And once we exceed the number of platform threads that we can create, then we are going to run into the out of memory error. Then let's see what are virtual threads. They are again the implementation of Java Lang thread, but once we create a virtual thread, the initial stack frame is created in the heap and not on the stack area, and it leads to a smaller initial memory footprint. So we can have a large number of virtual threads as long as it is supported by a heap size, right? And once the task which we assign to the virtual threads has to be executed, virtual threads makes use of the platform threads as a carrier to execute those tasks. And virtual thread gets mounted on the platform thread to execute that task. And once any virtual thread reaches any blocking operation, virtual thread unmounts itself from the platform thread, and the stack frame is moves back from the um, stack area to the heap. right? So, and then the platform thread picks other virtual threads for execution. And this leads to a lesser time of execution of multiple tasks and higher throughput. So let's see a visual representation of that. So these black arrows you can consider as the virtual threads, and each virtual thread corresponds to a task. So we have, say, thousands of tasks, so we can have thousands of virtual threads, and their initial stack frame will be in the heap. And once that task has to be executed, virtual thread is going to mount itself onto the platform thread. And what it will do is the stack frame of that virtual thread will move from heap to the stack area. And now once the task is getting executed and it hits a blocking operation, so what will happen is virtual thread is going to unmount itself from the platform thread, and that stack frame will move back to the heap. And this platform thread will pick other virtual thread for execution. And if this virtual thread task also hits a blocking operation, it will again get unmounted from the platform thread. And suppose the first virtual thread is now done with the blocking operation, then it will be again mounted over to the platform thread, and it will resume its task, and eventually that task will get completed. So you can see that my platform threads are never idle because of any blocking operation with this. One thing to note is this mounting, unmounting, and this scheduling of the virtual threads onto the platform thread is managed by the JVM and not by the operating system. So now let's see a few more concepts of virtual threads. So um, we can create the virtual thread via call of a factory method, which is of virtual, and they can also be created via executor service. So we'll see all this with the help of some code. Before that, we'll see when to use virtual threads. So virtual threads we should use for a smaller tasks which involve some blocking operation, such as any IO operations or a JDBC query or something. And we can have n number of virtual threads for n number of tasks. So we can have thousands of virtual threads. And it is not recommended for extended CPU intensive tasks. And we should avoid pinning of virtual threads onto the platform threads. So what is pinning of virtual threads onto the platform threads? So let's see that. So virtual thread gets pinned onto the carrier thread or the platform threads when it executes any code inside the synchronized block of code, or it calls any native method or a foreign function. So let's see that. Um, Suppose we have a blocking operation in a task, and we put that blocking operation inside a synchronized block of code. And for that task we create and for such tasks we create multiple virtual threads, right? So what will happen? So first the virtual thread is going to mount itself over to the platform thread, and it will start the execution of the task. Now it hits a blocking operation, but since that blocking operation is within a synchronized block of code, virtual thread won't be able to unmount itself from the platform thread. So eventually what will happen is this will make the platform thread to wait for that blocking operation to get completed. So um, what this will lead to is that my platform threads will be idle for some time and waiting for the blocking operation to get completed, and this won't give us a high throughput as we saw earlier. So we should avoid pinning of the virtual threads onto the platform threads. So next, what we will see is so these are few of the ways to tune, which we will see further. But let's now try to uh, jump to some code and see all this in action. So here I have a class with few methods, and first thing I'm going to demonstrate is I'm going to create um, 10,000 virtual threads for 10,000 tasks, and these tasks are having some blocking operation. So I'm making use of thread.sleep to simulate that blocking operation. So as you can see, what I'm doing is I'm creating a stream of integers ranging from 1 to 10,000. And for each integer, what I'm going to do is I'm going to create a virtual thread. I'm going to assign it a name, and then I'm going to start it. And to that start method, I'm going to pass a runnable via this lambda function. And this runnable is the actual task. So what I'm trying to do here is just printing a line on start of task. Then I'm going to hit a blocking operation, make my current thread sleep for 1 second, and then I'm going to say I'm done with the task, right? So I'm creating 10,000 virtual threads, and I'm trying to execute it. So remember, each virtual thread is executed by mounting it over to the platform thread. So it is a platform thread which will execute this piece of code, right? So let's see what happens. I'm going to run this, and it is completed, and the time taken is 2 seconds and 480 milliseconds. One important thing I would like to show here is if I go to my JConsole, and if I see this application, then if I go to the threads, so you're going to see that I'm having only 8 platform threads. So you see fork join pool 1, worker 1, and till worker 8. So whatever I did, there were 8 platform threads which were there, and there were 10,000 virtual threads. Right, so the virtual thread was getting mounted over to the platform thread. It was executing the code, and as soon as my virtual thread was entering into a blocking operation, that was the virtual thread was getting unmounted from the platform thread, and my platform thread was picking some other virtual thread for execution. So essentially, if you see, my platform threads were never idle. They were doing some task, and that's why all these 10,000 tasks were completed in a matter of 2 seconds and 480 milliseconds, right? And secondly, these the thing which I did just now, creation of 10,000 virtual threads. We can also do this by execute a service, in which case I'm going to create an implementation of executor service via executors.new thread per task executor. So this is what we use to create the virtual thread. So what is it's gonna do is uh, this is going to basically create a fork join pool of 8 platform threads. Why 8 platform threads? because I'm using a quad core machine with 4 CPU cores and 8 available processors. So a fork join pool will be created with 8 platform threads. And whenever I'm going to call this submit by passing implementation of runnable, for each submit there will be a new virtual thread that will get created and it will get executed after mounting that virtual thread onto the platform thread, those 8 fixed platform threads, right? So this is also a way to create virtual threads. Here I'm just having 300 um, tasks, so 300 virtual threads will get created. So let's quickly run this and check this out. So when I run this, so you see this also took a very less time, 151 milliseconds, right? And again, if I go back here and if I see the number of platform threads which got created, so you will see only 8 platform threads were created within this fork join pool, right? Next, what I'm going to show you is a comparison between virtual when we use virtual threads and when we use only platform threads. So let's see this out. So here what I'm doing is again I'm having 300 tasks and for which I'm creating virtual threads by via executor service of type new thread per task executor. I'm submitting it 300 tasks and I have a blocking operation which makes the current thread sleep for 100 milliseconds, right? And I'm going to take the snapshot of how much time it took. Secondly, what I'm going to do, I'm going to do the same exercise again, but this time I'm not going to create a virtual threads. I'm going to make use of a fixed thread pool, right? Going to use executor service to create a fixed thread pool of 8 platform threads, and I'm going to submit the tasks to it, 300 tasks. It also has a blocking operation to make the current thread sleep for 100 milliseconds. And then I'm going to compare the time taken with both the approaches. So let's now run this out and see. So let me run this. So you can see total time taken by virtual thread is 136 milliseconds and total time taken by the platform thread is 3 seconds and 842 milliseconds. Why platform threads took so much time is because I'm having a blocking operation, right? So if you say this, I'm having a blocking operation and basically platform thread is waiting for that blocking operation to get finished. So my platform threads are idle in this case, right? So that's why it leads to a lesser throughput and it takes a lot of time for the same number of tasks to get completed. Next, we talked about pinning virtual thread pinning over to the platform thread. So we are going to see that also in action. So let's see this. Having this and now the same thing, 300 tasks, creating 300 virtual threads and executing that task, having a blocking operation. But this time, this blocking operation is within a synchronized block of code, right? And what this will lead to is that my virtual thread won't be able to unmount itself from the platform thread, and eventually my platform thread will wait for the blocking operation to get finished and it will take a higher time to finish this 300 tasks. So let's see that in action. Let me run this and you notice earlier virtual threads took 136 milliseconds to complete this 300 tasks, and now if you run it, you will see that it's taking time. right? And I think it will take around 30 seconds. So let's see this. So why 30 seconds? Because I'm making each thread sleep for 100 milliseconds and I have 300 tasks. So it will soon get finished, I think 30 seconds. And so it took 29 seconds and 774 milliseconds. So make sure that whenever you are using virtual threads, then make sure that your blocking operation is not within the synchronized block of code. So just a quick recap of when to use virtual threads. So we should use it for smaller tasks which are having blocking operations. And we can have a large number or n number of virtual threads corresponding to such n number of smaller tasks. And it is not recommended for extended CPU intensive tasks. And we should avoid pinning of virtual threads onto the platform threads. So that's it, friends, with respect to virtual threads. I try to explain this in a quick span of time. You can read further about it and make use of it. It's quite helpful. Thanks a lot.